to solve the probability, our statistician have given different type of the theorem so that you can easily solve the problem of probability, like addition theorem, multiplication theorem, and so many other theorem we have gone through with this. And every theorem have some different use to solve the probability. In today's video also we will discuss a new one, theorem of the probability, that is called Bernoulli theorem. It's a very important theorem of the probability. Statistician Bernoulli have given this theorem, so on the name of him, this theorem is called Bernoulli theorem. When there are so many numbers of events and we are to get the probability of a fixed number of occurrence of an event, then we use the Bernoulli theorem. Suppose 8 coins we are tossing simultaneously, 8 coins is over there, and we are to calculate how the 5 head is over there. The probability of 5 head is over there when the tossing 8 coin is over there, or we can say 1 coin tossed 8 times, what is the probability of getting 5 times head is over there. It means when total number of events are n and we are to get the probability of a occurrence of r times, then we will use the Bernoulli theorem. So the formula for the Bernoulli theorem, that is NCR p raised to power r q raised to power n minus r. So here n is the total number of event. Here Bernoulli theorem we are having NCR p raised to power r q raised to power n minus r. So n is the probability of not, p is the probability of happening, p is the probability of happening, and q is the probability of not happening of event. N is the total number which is repeating is over there, and r is number where we are to calculate the occurrence of the probability. So this formula is NCR p raised to power r q raised to power n minus r. N is total number of event is over there. Suppose I am collecting 10 coin and throwing 10 coin. So the total number of event will be 10, and I am to calculate the probability of getting 7 head out of 10 coin. So the number of occurrence, that is 7. The probability for happening, that is p, and probability of not happening, that is q. So this formula is used for Bernoulli theorem. Again I am writing, that is NCR p raised to power r q raised to power n minus r. This is Bernoulli theorem, and it's very important when we are to calculate the probability. In today's video we will discuss how many types of the questions may be related with the Bernoulli theorem. The very first question we are having, suppose 6 coin, a coin tossed 6 times, a coin tossed 6 times, get the probability of getting 4 head among 6 coin. It means total number of event, a coin tossed 6 times, so n is equal to 6. We are to calculate the probability of 4 head. So the r is 4, the probability of getting head is 1 by 2, and probability of not getting head is 1 by 2. So in such kind of the question is over there, we have to use the Bernoulli theorem. In this, here the question is this, the first question, whatever, a coin tossed 6 times, get the probability of getting 4 head in 6 times. So n is 6, r is 4, the probability of getting head is 1 by 2, probability of not getting head is 1 by 2. So Bernoulli theorem is NCR p raised to power r q raised to power n minus r. So 6c4, 1 raised to power 4 and 1 by 2 raised to power 6 minus 4. So 6 multiply 5 divided by 1 multiply 2, 1 raised to power 4 and 1 by 2 raised to power 2. So 15 divided by 2 raised to power 6, because 2 raised to power 4 and 2 raised to power 6, and this come to 3. 3 5 are 15. 2 raised to power 6, it means 2 multiply 2 multiply 2 multiply 2 multiply 2 multiply 2. So that will be 2 raised to power 6. So 2 multiply 2, 4. 2 multiply 2, that is 4 multiply 4, that is 4. So that is 64. So that is 15 upon 64. So in Bernoulli theorem, if total number of event is n and we are to calculate the probability of occurring the event of r times, then we will use the Bernoulli theorems. We are having some more questions related to the Bernoulli theorem. Suppose 10 coin tossed. Question number second. Number of coin tossed, number of coin toss is 10. Getting the probability, first one, getting the probability that is n is equal to 7 head. Second, n is equal to less than 3 head. Third one, n is equal to 7 or more head. Fourth question may be n is equal to 0 head. Fifth question will be n is equal to 6 head. And seventh question, n is equal to all 10 head. I have taken a question. If one coin tossed 10 times, we are to calculate the probability of getting 7 head, probability of getting less than 3 head, probability of getting 7 and more head, probability of getting 0 head, probability of getting 6 head, probability of getting all 10 heads. So the very first one, R is 10, number of coin is 10, or the number of repetition of coin is 10, doesn't matter if 10 coin tossed simultaneously or one coin repeatedly toss up for 10 times. We are to get the 7 head. So R is equal to 7. In coin, probability of getting head is 1 by 2 and probability of getting not getting head is 1 by 2. So 10 C7 P raised to power 7 Q raised to power 10 minus 7, because formula first we are writing NCR P raised to power R Q raised to power N minus R. So 10 C7 P raised to power 7 Q raised to power 10 minus 7. So 10 multiply 9 multiply 8 divided by 1 multiply 2 multiply 3, 1 by 2 raised to power 7 and 1 by 2 raised to power 10 minus 7, that is 3. So this 3 3 is 9, this is 4. So 120 divided by 2 raised to power 10. So 120 2 raised to power 10. So 64 multiply 16. So 1024. So the probability of getting 7 head in 10 times the coin is toss up, probability of getting 7 head is 120 upon 1024. The second question is less than 3 head. Second question is less than 3 head. Now total number of event is 10 and the probability of getting 0, 1, 2 less than 3. So 0, 1 and 2. So there will be 10 formula is NCR P raised to power R Q raised to power N minus R. So 1 time r is 0, 1 time r is 1, 1 time r is 2. So this will be tan C0 p raised to power 0 q raised to power 10 plus tan C1 p raised to power 1 10 minus 1 q raised to power 9 plus tan C2 p raised to power 2 q raised to power 8. Firstly, we have written less than 3, so there may be 0. If they have written 3 or less, then we will use 3 also. But here the clear mention is that less than 3 head, so the head will be 0, 1 and 2. For getting 0, tan C0 p raised to power 0 q raised to power 10 minus 0 is 10, tan C1 p raised to power 1 10 minus 1 that is 9, tan C2 p raised to power 2 10 minus 2 that is 8. So this is 1 by 2 raised to power 0, 1 by 2 raised to power 10 plus 10 divided by 1, 1 by 2 raised to power 1, 1 by 2 raised to power 9 plus 10 multiply 9 divided by 1 multiply 2, 1 by 2 raised to power 2 and 1 by 2 raised to power 8. So this is 1 upon 2 raised to power 10 plus this is 10 upon 2 raised to power 10 because 9 and 1 10, and this is 45 divided 10 raised to power 10. So that is 56 divided 1024. So this is the probability. Probability is 56 divided by 1024. So in this question may be no problem at all. Here, if they write 3 or less, like in this question they have written 7 or more head. Okay, so next one question is over there. Next question is we are to calculate 7 or more head. It means the R is 7, 8, 9 and 10. Value of R is 7 or more head. 7 or more head, so 7 maybe 8, maybe 9 and maybe 10. More than 11 is not possible because total number of event is 10. So that will be 10. The formula is NCR P raised to power R Q raised to power N minus R. In coin P will be 1 by 2, Q is 1 by 2. So 10 C7 P raised to power 7 Q raised to power 7 10 minus 7 that is 3. 10 C8 P raised to power 8 and Q raised to power 10 minus 8 that is 2. Then 10 C9 P raised to power 9 Q raised to power 10 minus 9 that is 1. And 10 C10 P raised to power 10 Q raised to power 0. And Q raised to power 0 value is 1. Okay. So that is 10 multiply 9 multiply 8 multiply 1 multiply 2 multiply 3, 1 by 2 raised to power 7 and 1 by 2 raised to power 3 plus 10 multiply 9 upon 1 multiply 2, 1 by 2 raised to power 8 and 1 by 2 raised to power 2. Then 10 by 1, 1 by 2 raised to power 9 and 1 by 2 raised to power 1 and 10 C10 and Cn is equal to 1. So 1 by 2 raised to power 10 and 1 by 2 raised to power 0. So here there will be 3 and 4. So 120 divided by 2 raised to power 10 5 times. So 45 divided by 2 raised to power 10. Here 7 and 3 10, 8 or 2 10 plus 10 divided by 2 raised to power 10 9 and 1 10 and plus 1 divided by 2 raised to power 10. So this will be 165, 175, 176 divided by 1024, as we now 2 raised to power 10 that is 1024. So the probability of this will be 176 divided by 1024. So in this manner, in using the Bernoulli theorem, we can having the calculations of any questions is over there. No problem at all, or we can easily calculate the problem which over there. So for the probability of 7 or more is over there. then there will be 7, 8, 9, 10. So the probability is 176 divided by 1024. Next question, getting 0 head. Next question is getting 0 head. N is equal to 10, R is equal to 0, age we know the P is equal to 1 by 2 and Q is equal to 1 by 2. So 10 C 0, P raised to power 0, Q raised to power 10 minus 0, that is 10. So this is 1 by 2 raised to power 0 and 1 by 2 raised to power 10. Any item which it's 0, the value of this, so 1 multiply 1 upon 10 to 4, so the probability of 1024. So this also we have solved. Okay, now come to the next question. If questions is asking that getting the all 10 head, R is equal to 10, so there will be 10 C 10, P raised to power 10, Q raised to power 0, 10 minus 10 is 0. So this is value of 1, that y by 1 by 2 raised to power 10 and 1 by 2 raised to power 0. This value have 1 by 2 raised to power 0 will be 1, and NCN, that is also 1, so 10C 10 will be 1. So 1 multiply 1 upon 10 24 multiply 1, that is the 1024. So out, if total number of event is 10 and we are to calculate the value of 10, then this will be okay. Now one more question, you can calculate for 6, no problem at all. One is, if question is asking 3 or less than 3. 3 or less than 3 is written, it means R is equal to 3, 2, 1, 0. If they ask less than 3, then we will write 2, 1 and 0. But 3 or less than 3 is over there, then 3 will also include. So in such condition, 10C3, P raised to power 3, Q raised to power 7, then 10C2, P raised to power 2, Q raised to power 8, then 10C1, P raised to power 1, Q raised to power 9, and 10C0, P raised to power 0, Q raised to power 10. So that is 10 multiply 9 multiply 8 multiply 1 multiply 2 multiply 3, 1 by 2 raised to power 3 and 1 by 2 raised to power 7. Then 10 multiply 9 divided 1 by 2, 1 2 raised to power 2, 1 by 2 raised to power 8 plus 10 divided by 1, 1 by 2 raised to power 1 and 1 by 2 raised to power 9, and 10C0, the value of 1, 1 by 2 raised to power 0 and 1 by 2 raised to power 10. 10C0 value will be 1. So that is 120 divided by 1024. This is 3 times, this is 4 times. Plus 45 upon 1024, this 5 times. Plus 10 upon 1024 plus 1 upon 1024. So againly 176 divided 1024. So in this manner, if the Bernoulli theorem is over there, any type of the question is over there, you can easily calculate with the help of the Bernoulli theorem is over there. So this theorem is very easy. If you will having some command on the Bernoulli theorem, you can easily calculate questions with the help of Bernoulli theorem. We are having some more questions related to this. This was the second questions of Bernoulli theorem. We are having another one question. The probability of a student will be graduate is 0.4. P is equal to 0.4. Total number of student is 5. The probability of getting 0 will, probability of getting all 5 will, probability of getting less than 2, 2 or less than 2. Third, fourth, 4 and more. Okay. At least 1. Next one is at least 1. The question is that probability for becoming the bachelor degree of a student is 0.4. 5 students are giving the examination. Get the probability of getting 0 bachelor, getting all 5 bachelor, getting 2 or less than 2 bachelor, getting 4 or more than 4 bachelor, and at least 1. So here we will say the n is equal to 5. Probability is 4 upon 10. We are having 2 upon 5, and the value of q is equal to 3 upon 5. Because p is equal to given 0.4, as we know p plus q is equal to 1. So 0.4 plus q is equal to 1. So the q is equal to 1 minus 0.4. So the q value will be 0.6. P is given 0.4. So the p value will be 2 by 5 and q is 0.6. So the q value is 6 upon 10 of having 3 upon 5. So the very first, the probability is 2 by 5 and q is equal to 3 by 5. Okay. The very first we are having p is equal to 0.4. So point disturb. So 10 is over there. So the probability is 2 by 5 and probability of not occurrence is 3 by 5. Now 1 by 5 question we will solve. Value of n is equal to 5 and r is equal to 0, then 5c NCR p raised to power r q raised to power n minus r, that is the formula. So first one 5c0 p raised to power 0 q raised to power 5. So the value of 1, 2 by 5 raised to power 0 and 3 by 5 raised to power 5. So 1 multiply 3 raised to power 5 and 5 raised to power 5. So 243 divided by 5 raised to power 5, 3125. So the probability will be 243 divided by 3125. That is for 0. Second question, we are to calculate all 5 students will pass. So here probability of getting r is equal to 5. Then 5c5 p raised to power 5 q raised to power 0. So value of 1, 2 upon 5 raised to power 5 and 3 upon 5 raised to power 0. So 3 upon 5 raised to power 0 will be 1. So that will be 1 multiply 32 upon 3125 multiply 1, that is 32 divided by 3125. 2 raised to power 5, that is 32. So for getting all 5 students will pass, the probability is 32 divided by 3125. It means there is a very little chance for getting all students pass. Now third is to calculate, and that is 2 or less than 2. 2 and less than 2. So the value of r is equal to 2, 1 and 0. 2 and less than 2. Okay. So 2 may be, 1 may be, 0 be. So there will be 5c2 p raised to power 2 q raised to power 3, 5c1 p raised to power 1 q raised to power 4 and 5c 0 p raised to power 0, so q raised to power will be 5. So there will be 5 multiply 4 multiply 1 multiply 2, 2 upon 5 raised to power 2 and 3 upon 5 raised to power 3 plus 5 divided by 1, 2 upon 5 raised to power 1, 3 upon 5 raised to power 4 plus this is 1, 2 upon 5 raised to power 0 and 3 upon 5 raised to power 5. So this is 10 multiply 2 raised to power 2 multiply 3 raised to power 3 divided by 5 raised to power 5 plus 5 multiply 2 multiply 3 raised to power 4 divided by 5 raised to power 5 plus 3 raised to power 5 upon 5 raised to power 5. So this is 3, 1, 2, 5. 27 multiply 4 multiply 10, 1080 plus 27 multiply 3 multiply 10, 1110. 243. So the result will be 2433 divided 3125. So this will be probability of getting 2 or less than 2 student will pass. The probability is 2433 divided by 3125. If the question are asking 4 and more, so 2 or less than 2, 2, 1 and 0 we have to write. It's very simple. Now if we want to calculate 4 and more will pass, so the R will be 4 and 5. So 5c4 p raised to power 4 q raised to power 1 and then 5c5 p raised to power 5 q raised to power 0. So that will be 5 upon 1, 2 upon 5 raised to power 4 and 3 upon 5 raised to power 1, and this is value of 1, 2 upon 5 raised to power 5 and 3 upon 5 raised to power 0. So this will be 5 multiply 2 raised to power 4 multiply 3 upon 3125 plus 2 raised to power 5 upon 3125. So this will be 15 multiplied by 16. So there will be 240 plus 32 divided 3125. Because 2 raised to power 5 is 32. Or we can write 240 upon 5 raised to power 5 plus 2 raised 32 upon 5 raised to power 5. So 272 upon 3125 will be answer, because as we know 5 raised to power 5 is 3125. So in this manner, if any type of the question is over, easily we can calculate with the help of Bernoulli theorem. One more question, if asked at least one event, then also we have to calculate. If at least one event is over there, so the very first we will calculate for the 0 event. So that will be 5c0 p raised to power 0 q raised to power 5. We have already calculated this, that is 243 divided 3125. Or one time we can calculate 1 multiply 2 by 5 raised to power 0 multiply 3 by 5 raised to power 5. So this will be 1 multiply 3 raised to power 5 upon 5 raised to power 5, that is 243 upon 3125. At least one event. that is 1 minus probability of 0. So 1 minus 243 divided 3125. So that 3125 minus 243 upon 3125. 2882 3125 will be answer. So I think with the help of this video, you may be learn how to calculate Bernoulli theorem. It's very important term of the probability, and this contains a lot of value in probability. So you may be learn how to calculate Bernoulli theorem. In next video also we will having some more practice of the Bernoulli theorem. I think this video will be helpful for you to learn how to calculate probability with the help of Bernoulli theorem.